Howdy, ladies and gentlemen. Standard 4.3, solving equations by multiplying or dividing. Standard 4.3, I can solve one-step equations by multiplying or dividing. Remember, inverse operations, we talked about this before. Operations that undo each other to get the variable alone. We had two of them. We had addition and subtraction, and we talked about multiplication and division. All right, remember these are the opposites, the opposite operations. That's why it works. All right. Division property of equality says that you can divide each side of an equation by the same number. Solve each equation. Check the odd answers. So, first off, we need to read this problem. It's going to say, question 1 is 5 times x equals 20. We want to know what x is. So to do that, we want to undo what's happening to the x. So we're going to go in here and do the opposite operation. The opposite of 5 times something is to divide by 5. I'm going to go across. Remember that imaginary fence there we talked about before? Go across, divide both sides by 5. Work our way down. Let's see. 5 divided by 5 makes 1. So instead of writing 1x, we're just going to write x. 20 divided by 5 is 4. All right, we can plug that back in. We can say 5 times 4 equals 20. 5 times 4 does make 20. So 20 equals 20. Check. X equals 4. All right, let's look at the next one. Here we have negative 2 times x equals 34. So I'm going to divide by negative 2. You want both the sign and the number. Negative 2. Those cancel, leaving just x. 34 divided by negative 2 is going to give us, let's say, positive divided by negative is a negative. 34 divided by negative 2 would be 17. So we have negative 17. All right. Negative 17. All right. Next one. All right, for question 3, we have 14 times h equals negative 42. I'm going to get my color here. Let's do blue. Divide this side by 14. Divide this side by 14. 14 divided by 14 cancels out, leaves h. 42, negative 42 divided by positive 14. So negative divided by positive is negative. Negative, there we go. 42 divided by 14 would be 3. We're going to test that back out. 14 times negative 3 equals negative 42. If you punch 14 times 3 in the calculator, you get negative 42. So we get negative 42 equals negative 42. Check. All right. Let's read the next one. 4 equals negative 9 equals negative x. That's tough. So here's what we need to think about. That's not really negative x. That is actually negative, so let's write over here, negative 1x. All right. So when we divide, we're going to divide both sides by negative 1. Right? Negative 9 divided by negative 1. Remember, we're picking that negative, not negative 9 on both sides. We're picking the number and the sign that's with the x, because we want to get the x by itself. We can evidence that because this side just becomes x, right? Negative 1 divided by negative 1 makes 1, so x stays. Negative 9 divided by negative 1. Negative 9, or sorry, negative divided by negative is positive. 9 divided by 1 is 9. So x equals 9. All right? These are tough here. Let's keep going. Real life examples. The United States population in 1998, 270 million, was twice the population in 1943. Find the 1943 population. Let's call that P. Okay? We're going to call 1943 population P. So we're saying that 1998 was twice 1943. So we know that we need to multiply the one that's smaller by 2 to make it the one that's bigger. So we'll say 270, we're going to make our answer in millions, equals 2 times P. All right? To solve that, we want to get P by itself, so I'm going to divide by 2, divide by 2. Those cancel to leave P. 270 divided by 2. If I type that in the calculator, I'm going to get 135. And we actually want to say P equals 135 million people. That sounds right, right? We know that 1998 was bigger than 1943, right? 270 million is double 135 million. That makes sense. Also, by the way, 1998 is when I graduated high school, guys. So that's how old I am. Next, we also have this multiplication property of equality. The multiplication property of equality says that you can multiply the same number to each side of an equation, just like we've been doing, and it keeps the equation equal. So to do that, to demonstrate that, we're going to do it this way. We're going to say, okay, x divided by 9 equals 3. I want to undo the divided by 9, so I'm going to put a dot and a 9, and a dot and a 9. That means I'm going to multiply both sides by 9. Just like before, 9 times something divided by 9, the 9's cancel to leave just the letter. 3 times 9 makes 27. All right? If we check that, we're going to say 27 divided by 9 equals 3. 27 divided by 9 does actually equal 3. It checks out. Right, this one, we have y divided by negative 30 equals 6. We're going to multiply by negative 30. Multiply by negative 30. That's going to cancel and leaves y. 6 times negative 30 is going to make a negative 180. Right, that's our answer. Y equals negative 180. Next. 3, we have x divided by 12 equals 0. I'm going to multiply both sides by 12. Those cancel, leave x. 0 times 12 makes, you got it right, 0, so x equals 0. This would have made 0 regardless of what number was down here, just how it works out. And here's our last one. 5 equals t divided by 2. I want to get the letter by itself, so I'm going to deal with this one here and do times 2 and times 2. These cancel to leave t on the right. 2 times 5 makes 10. Our answer is 10 equals t. Let's go back. I missed a proof on this one. We're supposed to prove the 3's. So I'm going to go back and put my 0 up here. So I'm going to have 0 divided by 12 equals 0. 0 equals 0, right? 0 divided by 12 does make 0, so that checks out. Sorry about that. All right. Here is our 4.3 homework. Look what we have to do. Date's November 5th. Here's all the questions we need to do. Show us all of the work or it's going to get returned to you. And then remember down here, 19, 20, 21, we're doing kind of what we did beginning of last week, right? Decided the solution. We'll keep those skills fresh. Here's some word problems. Give those a shot. These are a little trickier. These would be a good thing to join us for the live session to be able to see, all right? Good luck.